Good afternoon to all of you. Welcome you guys. Welcome you all. How you are doing everybody? And so I think we are live. So सबसे पहले बोलिए now here is the audio video is clear to everybody? चेक करके बोलिए. Is the audio video is clear to everybody? Do comment करके बोलिए. Hmm? Yes. So चलिए. And is the audio is video is clear to everybody? Am I audible to all of you? चलो a great news to the aspirants of 2027-2028 वाला को. So you can celebrate the new year little early. Finish the year a step closer to success. Start your gate preparation just 3,999 only. 3,999 only. The offer is valid only for 28th only. इसके साथ आपको 2 months का free extension भी मिलेगा and gate assured plan भी आपको मिलेगा. So you can enroll for this thing by using a code of BVREDDY. Use the code of BVREDDY and to have a great learning experience from the top educators team. And these are the ESC 2025 rankers from Unacademy. Many ranks are still counting. So we are offering the test series for the aspirants of 2025 के लिए, that is the test series for all 2026 वाला को you can have a look at. So these are the 2025 gate के लिए you can have a look at now. And Kurukshetra batch, and this batch we started for the 2028 के लिए. So you can see now the students who are preparing for 2028 this batch. And 2027 का भी batch शुरू हुआ, that is December 27th onwards the new batch is started. And you can see now Unacademy starters kit which is you can get from the Unacademy store से आपको मिलेगा. What? Screen is not visible. Sorry. Yeah, is the screen is visible now? Yeah, sorry. So here, now you can have a look at now here. Now you can plan your Unacademy. So here, this is 1 year. So here, so we are starting the, you can complete your new year. So before only compared to others. So you can start your gate preparation just 3,999 only. इसके साथ आपको 2 months का extension भी मिलेगा and gate assurance plan भी आपको मिलेगा. You can use the code of BVREDDY to avail these great opportunities. Okay, with this year-end sale, so you will have a 55% of discount. Use the code of BVREDDY. These are the rankers from Unacademy team. Have a look at now here test series. we have started the new batches for 2028 and 2027 के लिए. This is a new batch for 2028, and to enroll for it you can use a code of BVREDDY. Use a code of BVREDDY. एंड 2027 के लिए भी नया बैच हमने लॉन्च किया. So this Unacademy starters kit. And so another thing is we are starting a new course for the West Bengal electricity department के लिए. So the new batch is starting from the 19th December onwards. Yeah, so you can use a code of BVREDDY and to avail this great opportunity. Crash course we started is running. And Unacademy, so Unacademy AI tool, you can see now here with this you can directly interact with the AI tool. There are three different type of modes are there: voice mode, quiz mode, summaries, smart summaries mode. So if you simply upload the file whatever you have, so then simply if you ask they explain, they will explain, and quiz they will create, and smart summary, it will summarize the complete data. And the test series which is live from April 1st onwards. And we do offer the 2 subscriptions आपके लिए, प्लस वाला, आइकॉनिक वाला. प्लस में आपको टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स, evaluated test series, and structured courses and PDF, live quiz, unlimited access. And आइकॉनिक में आपको क्या एक्स्ट्रा मिलेगा? पर्सनल कोच मिलेगा एंड फिजिकल नोट्स मिलेगा. Right. You can start your preparation with the Unacademy to avail these great opportunities. These are the GATE 2025 rankers from Unacademy. So you can have a look at now AAR2, AAR2. This is AAR3. These many ranks are from Unacademy only. Have a look at. Chalo, let's continue here. Yeah, last class we have completed. How many? What topics we have completed? You can see now here. We have finished up to multiplexes. We started, I think so, isn't it? Multiplexes we have started now. Multiplexes we started, right? So those things will continue now. And by today's class we'll finish the multiplexer. Thereafter we start the sequential circuits. Right. This problem we have finished now. Chalo, next problem. Message kiya? Okay, fine. I'll share all the class PDF. I will share you. I'll share you all the PDF. I will share you. Don't worry. Okay. So here, and do remind me one more time. So after completion of class, I will share all the PDF. I will share you. Right. This problem completed. Okay, very good. Next, take this problem. Take this problem. A mux circuit shown in the figure below implements a logic function f1. So the correct expression of f1 is. Now you tell me now, let us find this one here. We don't know, let us call this, if I call it as something f2, if I call this is f1 given. So let us find this f2 value. Yeah, tell me for f2. It is equal to, yes, when this is y bar. So here 0 given here na, 0 given, 0 ko kya connected here, x bar connected plus y into they connected x. Okay, so that is what I can say. This is nothing but x bar into y bar plus x into y. So this is nothing but x naught, y na. Now this F2 is the selection line here. Now you tell me now from this we can get this F1 value. What is F1 value? Tell me. This is F2 bar. When it is bar 0 connected to Z bar. So this is Z bar plus F2 into Z. Okay. Now, so what is this you see here? What will come now? Tell me. Yeah, this is nothing but yes, F2 XNOR with Z only na. So that means what we can say, this is F2 XOR Z whole bar. Now this F1 which is equal to F2. How much is F2 here? This thing. So XNOR we can write as what element of here? Complement of XOR we can write. Complement of XOR we can write. So we'll come it as what element of here? X XOR Y whole bar XOR with Z ka whole bar. Isn't it? So कौन सा option satisfy होगा? Tell me. So that is option B na. Next. Now find the Z output expression we need to find. Yeah, if we observe carefully this expression here, we'll get it as what element of Y. This is Y, and here we have this is C. Now the Z, so I can say this as Z equal to what? Tell me. Y plus C. Z equal to Y plus C. So what is this Y? You tell me now. Y. You can see now here what is the min terms are. So 0 min term 1, 2 and 6. Okay. So here how we write the 0? You tell me. A bar, B bar, C bar. 1. A bar, B bar, C. Next 2. A bar, B, C bar. Plus 6. A, B, C bar plus C. Okay. Now you tell me now what I can do. So here, so C. Now I will take out the common. So here this is C bar now. C bar. Okay. Bubble. So this means here, here, here I have taken C bar common. Then will come to be a what element of 1 plus A bar B bar plus A bar B A B plus what element of here? A bar B bar C. Then which will come to be a 1 plus anything is 1 only na. That is A bar B bar C. We can apply mingle property here. C bar plus A bar B bar. So this is answer. Tell me. So कौन सा option? Option C. Next, yeah, tell me now here in this case what I will get my output. Here we are calling this output is y1, this output is y2. Then finally this is output y. Tell me now what will come this y1. Here this is the selection line here, and this is the selection line. Now you tell me now what I will get this y1 here. Y1 which is equal to G0 bar into I0 plus G0 into I1. Okay. Next, what about this y2? You tell me. Y2. Here we'll get this y2 will come now. So what we'll get now here? So the selection line is G1 now. So that means G1 bar into I2 plus G1 into I3. Now, so this value is y1 and this value is y2. And from this we'll get this output now here O. And that is given as what tell me now here the selection line is what tell me now G2 now. So then this is which is equal to G2 bar into y1 plus what will be now G2 into y2 and G1 G2 bar into y1 value we have what will be now here G0 bar into I0 plus G0 into I1 plus now G2 into y2 is what will be now here G1 bar into I2 plus G1 into I3. So from this we can get this O as we multiply. So what I will get you tell me now here G2 bar G0 bar into I0 plus G2 bar G0 into I1 plus G2 G1 into I2 plus G2 G1 into I3. Now you can see the terms now what we have. G2 bar, G0 bar, I0. So which option will satisfy you tell me now here. So option C will satisfy ना check करके बोलिए. Next. And tell me the next one. The output of the multiplier circuit shown in the figure is here. So these bars are visible to you. Check karo. This bar is also there. Now you can tell me now expression how we can write. So this expression which could be given as what, tell me? A bar B bar into C. A bar B into C bar. A B bar into C bar plus A B into C. And you can see the minterms here: 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. So from this, what I can say, the minterms are, and which is equal to 1 comma 2 comma 4 comma 7. So this is nothing but what, tell me now here? 3 input XOR gate na. So this option. Next. And take this problem. Consider 4 to 1 multiplexer with a 2 input, 2 lines S1, S0 given below. The minimal sum of the product form. The expression we need to find. Yeah, try it now here. So that is F, which is equal to what, tell me now? Yeah, P bar Q bar into 0 plus P bar Q into 1 plus P Q bar into R plus PQ into R bar. This bar is visible. Here the bar is there. So how much this expression you tell me now here? So that is P bar Q plus PQ bar into R plus PQR bar. Now let's try to minimize it now. See, the options are what form they given. Options will contain P bar Q is there, isn't it? Now what I am doing here, in this, if we have taken Q common, then it is P bar plus P into R bar plus PQ bar into R. Then F is equal to Q into, so this is equal to P bar plus R bar plus P Q bar R. Now this is given as, you can see now, P bar Q plus Q into R bar plus P Q bar R. So you can see this is option A is there now. And the next one. The multiplexer circuit functions as, this multiplexer will behave as what they ask him to find. Now see, the options are given: full subtractor, full adder, 2 output comparators, off adder. Let's find out this output expression. Based upon that, we can talk about the nature. So let's talk about this output here. Here X is connected now. So this is X. Here we have, this is X bar, and this is also x bar, and this is x. Okay. Next here this is connected to 0, and this is connected to x, this is connected to x, this is 1. Fine. Now let's find out the P now here first. Tell me for P now. So that is P of x comma y comma z, which is equal to what we can see. P may here what we have. Now selection lines are y z. So this is we can say now y bar z bar, and that is connected to x plus y bar z into x bar plus yz bar into x bar plus yz into x. So this is what we'll get now here, x y bar z bar plus x bar y bar z plus x bar y z bar plus x y z na. So can you find out the minterms of this expression? 1 0 0 0 0 1 0 1 0 1 1 1. So from this you can tell me the minterms are what we have. So this is 1 is there, 2 is there, and 4 comma 7. 1 2 4 7 means what is this thing here? Either sum or difference hoga na. So this means from this we can say this as maybe that is a 3 input XOR gate. So that is X XOR Y XOR Z I can say. From this we can say maybe a sum, maybe a difference hoga. Now let us talk about the Q now here. Q of X comma Y comma Z. Yeah, you tell me now how much will come this Q, say what will get, you see. Now this is y bar z bar into 0 plus y bar z into x plus y z bar into x plus y z into 1. Now simplify it. So what I'll get, you see this thing here, x y bar z plus x y z bar plus what will be now y z. Now you can tell me the minterms of this expression. 1 0 1 1 1 0. So that is 0 1 1 1 1 1. So what will be the minterms, you tell me now finally. For Q का minterms क्या है? X Y Z. Q का minterms you can see now here. So those are 3 5 6 7. 3 5 6 7. This is nothing but what element of carry, only in a full adder carry. And so I can say this could be the sum and carry. So this is nothing but what element of full adder. Okay. From this we can conclude this as a full adder. Done. Next. And take this next one. The expression for y is the expression for y is, and offered as sum and carry given as the selection lines. Okay. Okay. Now you can tell me the expression for y. So this is y, which is equal to. Now here we have S1 is connected. This is S0 is connected. Now you can tell me now here. So what I can say, this is S1 bar into S0 bar into C plus S1 bar S0 into C plus S1 S0 bar into C bar plus S1 S0 into C bar. Okay. Now, so first, if I combine these two, if I combine here, first these two I am combined and these two I am combined. Now tell me now what will come. If I combine these two, so what I will get now here, this is S1 bar S1 bar into C will come now, plus next what else you can see, S1 into C. Okay, S1 into C bar. So then this Y value which is come to be a, what you can see now here, S1, what's happening here, S1 XR with C. So this is, what is this Y value, tell me now here. From this Y is equal to, what will come, S1. S1 is what element of this one now, which is nothing but what element of here, A XR B. So from this we can say this as A XR B XR with C now. So what should be the option, tell me now. Option A. Okay. Next. Enter this next one. Now you tell me now here, which is going here, this is D now, and here we have this is C plus D whole bar, that means C bar into D bar, and this is CD, and this is 1. So you can tell me the expression now here. Yeah, what will get this expression now? F is equal to. So this is A bar B bar into D plus A bar B bar into C bar into D bar plus A B into CD plus AB. So they asked him to find the minterms now. Let's find the minterms now here. So this is 0. Now this is 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0. Hmm? Next, this is 1, 1, 1, 1. So this is 0, 0, 0, 1, 1, 0, 1, 1. 1, 1, 1, 1, 1, 1, 1, 1. Now you tell me now here. So which could be given as, and what are the minterms you can see now here? 1. Okay, so here this is 3 here, this is 4, this is 15, so 12, 13, 14, 15. 1, 3, 4. 11, there is no 11 now here, 11 is there. Okay, so this is A, B bar. Here, why 15 here? This is 1, 0, 1, 1 now. So that is, this is 13. Okay. There is no 11 now. 11 we are getting. Is it possible to get the 11? Hmm? 1, 3, 4. So this is 12 I am getting. Hmm? 11 is there. Where we have missed the things now, tell me. A bar, B bar into D. A, B bar into C bar, D bar. Hmm? Yes, how we got? Equation, am I written any wrong? Let me check once again. So that is given as what is A bar, B bar into D plus A, A bar, B into C bar, D bar. Next, A, B bar into C, D na plus A, B into 1. Tell me now in terms here in these cases we have 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, sorry, 0, 1, 0, 0, 1, 0, 1, 1. So this value 1, 1. So this is 0, 0, 0, 1, 1, 0, 1, 1. Where is the 11 here? Hmm? third term 1 1 CD only now. This is C bar D bar. Okay, this is 1 only. Okay, so which we have, this is what I know, 1 comma 3 comma 4. This is 11 12 13 14 15. Yes, correct only. Correct only now. Yeah, correct only. Yeah, that is 11. Okay, so I thought this is 13 I have taken. So this is 11 only now this term. It's a mistake. Next. Take the next one. Here, this is a bubbles are visible not. You can see these bubbles. Here they given this is I0, I1, I2, this is I3. And this is a NOT gate. And this is a AND gate. This is S1 and this is S0. Tell me now F is equal to, so here we have C, here we have D. Okay, next. Here we have, this is C bar. And here we have C bar into D bar. Okay? Tell me now. Now F is equal to what? Tell me now. A bar B bar into C. A bar B into D plus A B bar into C bar. This is A B into C bar D bar. Tell me in this case min terms. We have 1 0 0 1 0 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 0 1 0 0 1 0 0 sorry 1 1 0 0. So tell me the min terms. We have this is 2 comma 3 comma, yes, 5 comma 7 8 9 12. So कौन सा option you see? D. Okay. Next one. In the circuit shown, W, Y are MSBs are the control input, the output F is. Now here this is connected to ground, so this value 0. VCC means what? Logic 1. This is logic 1. This is 0. And here this and this are connected to ground, so that's why 0. So first we'll get this Q will come. And Q will come to be what? Tell me now. W bar X bar into this is 0 plus W bar X into 1 plus W X bar into 1 plus wx into 0. So what is the cube will come? W bar x wx bar. So from this, which we can say this as w xr with x. Okay, right. Next, here we have this is q now. Q is given to these two. These are zeros. Now you tell me now what will come it as f now. F is equal to y bar z bar into q. Y bar z into q. So if I combine this thing, so y bar z will come now. So this will come it as y bar into q. So this q value, that is y bar into q, is equal to w xr with x. Then f will come to be a y bar into w bar x plus w x bar. Check it now. We multiply option C now. Multiply to y bar. Take this one. Mux is a very important. So mux mostly will get the problems from multiplexer से आएगा. Now tell me this one. 8 cross 1 mux is used to implement the logic function they given. So tell me now f now. What is output now? Y, which is equal to so you can see now here a bar b bar c bar into 0 plus a bar b bar c into d plus a bar b c bar into 0 plus a bar b c into d plus a b bar c bar into 0 plus a b bar c into 0 plus a b c bar into 1 plus a b c into 0. Now this is given as a bar b bar c into d plus, right, so this term is 0, this term is also 0, this is 0, this is also 0, this is 0 now, and non-zero terms we'll see. Now this is a bar b bar c d. No, this is already written now. This is a bar b c d plus a b c bar. Now, so try to simplify this thing. What I can do here in this y, which will come to be a. I can take out what tell me now here in this. A B C bar. In these two, what I can do now here? A bar C D we have taken common. B plus B bar is 1. A B C bar. So option C. Next. Now take the next problem. Design a logic circuit by using a suitable mux. So here how many inputs are there? You see this thing, 3 inputs. With the 3 inputs, what the size of the mux required? You tell me now. What the size of this mux required? So 8x1 mux is required. Suitable mux. We required 8x1 mux. 4, 5, 6, 7, 8. And 3 selection lines we have taken. So this value, I can say this as I0, I1, I2, I3, I4, I5, I6, I7, then this is S, S2, S1, S0, and this is Y. And we can say this as inputs are A, B, C. Now you can see now they need what, tell me now, minterms are what minterms are required. Minterms, which minterms we required here? M of 0, 1, 3, 6, 7. So that means here what we required now, 0 required now, so that's why that is given to 1. 1 is required, so 2 not required, 3 required, 4 not required, 5 not required, 6 required, 7 required. Okay, whichever is required, those I connected to a 1, remaining are connected to zeros. Okay. Done now, all of you. Now see this problem. Design a logic circuit using 4x1 mux. 4x1 mux we have to use to design this one. They given the options. What they given now? First case AB are the selection lines. Next BC are the selection lines. AC are the selection line they are saying. Okay. Let's try to implement now. First AB are the selection line. Now they are asking to take the 4x1 mux now. They are asking to use the 4x1 mux. Now here it has a 4 inputs. And 2 selection lines are there. And this finally this is Y. I0, I1, I2, I3. So this is S1 and S0. So here A and B are the selection lines. I given A and B. And this Y. So the C is there now. C is missing. C should be connected somewhere. I need to connect now here. Let's see how we'll connect this C now. Yeah, so C connection के लिए, so what I am doing is I'm using one technique I'm using, that is called as Maha technique. That is what? Tell me. Maha technique. Maha technique is what you see in this case. So we have the terms as what? Tell me. A, B, C. This is 2 power 0, 2 power 1, 2 power 2. And so we need to kind of C as connected. So C means how much? 2 power 0. So that means weight of C is how much now? Weight of C is 2 power 0, that is 1. Weight of C is 1. So that's why we need to give the numbers we have to give here. So first we start with the 0 comma 1. Thereafter 2 comma 3. Next 4 comma 5. 6 comma 7. Now you see the y, what is the min terms we required here? They given that f is given us what? Tell me. Min terms are 0 comma 1 comma 3 comma 6 comma 7. These are the min terms given, right? And you can see now here. First, here 0 and 1, what we required of both are required. Both are required, that's why here it is connected to 1. In this, so here what we 2 and 3 may what we required now, only 3 is required. 3 is what? Tell me now. Upper bound. Upper bound के लिए what we should see? C connected. Upper bound now, so that's why C is connected. Next 4, 5 may what we required? 4 is not required and 5 is also not required. Both are not required, that's why it is 0. And 6, 7 may what we required? Both are required, so that's why it is connected to 1. Understood this Maha technique? That's it. The circuit is over. This is now we did for what terminal by taking the AB as a selection line. Now I will do by taking the BC as a selection lines. Upper bound means now here this is, so here we have 0 and 1 is there now. 0 comma 1. So we can call the 0 is called as a lower bound and 1 is called as an upper bound. Okay, so here now once again look at now here. So what we require now here, what is available? You see 0 is available, 1 is available. In the 0 and 1, which is required here? Both are required. Both are required. Then we should connect here. 1 is connected. Okay. Next here, what is available? 2 comma 3 is available. 2 and 3 में what we require now? केवल हमको 3 चाहिए. 3 is what? Tell me now. Upper bound, bigger value na. Upper bound means bigger value. In this, 3 is upper bound. Upper bound I to C connected. Now here we have 4 and 5. What we required? So here both are not required. 4 and 5 not required. Now here my min terms. That's why that is 0 connected. And 6, 7 may what we required now? 6, 7 both are required. That's why it is connected to 1 is connected. Right? This is a Maha technique. Then C bar. If it is lower bound is required, C bar. Next, in the second bit, we will get to know now. Now let us see the B bit now. BC as a selection line. Tell me now by taking the BC as a selection line. So this is 4 cross 1 mux and 4 inputs now. And this is what will be now I0, I1, I2, I3. So selection line S1, S2, this is Y. Yeah, you tell me now what we should do here. BC as a selection line we have connected first thing. Next, and so we need now here. So see this thing BC selection line means A has to be connected. We have see the A, B, C. What the weight of A you tell me now, that is 2 square now. That means how much now? 4. Weight of A is how much? 4 is a weight. So you can see now first. So the numbers. So we should write as 0, 1, 2, 3, 4, 5, 6, 7. So first we have taken 0, we started. And what the weight of A here? Weight of A is how much? 4. So 0 plus 4, add 4. If we add 4, will come it as what? Tell me now here. 0 comma 4 will come now this one. Okay. We added 4 is added. Now this 0 over 4 is over. Now what is the least value here? Least value is 1. So that's why we can say this as 1 plus 4. 1 plus 4 is how much now? 5. That means 1 completed, 5 completed. What is the least value now? 2. That is 2 comma 4 add. So this means 2 and 6. Next, what we have, tell me now? 3. 3 plus 4. 3 plus 4, which is a 7. Okay. Tell me this one, everybody. Understood how I wrote? Now finally you tell me now what are the minterms we required. 0 comma 1 comma 3 comma 6 comma 7 we required. Now here you see this thing, what has to be connected. Here we have 0 comma 4 is there. What we required now? 0 comma 4 में केवल 0 required. So what has to be connected now? 0 required means, so that is A bar we have connected. Next 1 5 में what we required now? 1 is required. Lower bound now, so that's why A bar. 2 6 में 6 required upper bound. That's why it is A connected. 3 7 में both required, so that's why 1 connected. Okay. Done. Now let's see the AC or the selection lines. Four inputs, two selection lines, and one output. So you can see now this is, so this is I0, I1, I2, I3. So this is S1, S0, this is Y. Here this is 4x1 mux. Here what are the selection lines to be taken? Here AC is the selection line, AC. Next B has to be connected. So this is A, B, C now. What is the weight of B? You tell me now. 2 power 1 means what? Tell me now. 2 now. So means how should be taken now? You can tell me now. So these are 0, 2. Next 1, 3. Next 4, 6. Next 5, 7. So you can tell me the min terms are 0, 1, 3, 6, 7. Now you tell me now what we required in this case. 0 and 2 may what we require now? 0 is required. So lower bound now. So that is B bar. 1, 3 may both are required 1. 4, 6. 6 required. So that's why what I can say now B. 5, 7. 7 required. That's why it is B. Okay. Completed. Now tell me this one. Eight cross 1 marks. So they ask him to implement. Now see what they given now here. F they given what they given a pi of 1, 5, 12, 15. That means they given max terms, convert into min terms 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Okay. Now you can see now. Now, as usual, we can apply Maha technique. The A, B, C, the selection line they has taken. D is the, we need to place now here. Tell me now D, how I can give the numbers now. Tell me now D weight is what? Tell me 1. So that is 0, 1. So this is 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right now you can tell me now here. So here 0 and 1 में what we required? Only 0 is required. 0 के लिए क्या connect करना पड़ेगा? 0, 1 में only 0 required ना. 0 के लिए what I need to connect now here? Lower bound ना. Lower bound either D bar we should connect ना. 2, 3 में both are required. So that's why 1 is connected. 4, 5 में only 4 is required. Lower bound. So that's why D bar. 6, 7 both are required. So 1 is connected. 8, 9 both are required. So 1 is connected. 10, 11 both are connected. Both are required. 12, 13 में 13 required. So that means upper bound. So that is D. 14, 15 में D bar. Lower bound. चेक करके बोलिए. ऑप्शन डी ना. Which one? So check करो. Which option? D bar 1. Option B. Got this point here. This Maha technique बढ़िया. ये तो बहुत बढ़िया मेथड आई. Next, try this one. In this case also we can apply the Maha technique. They given YZ connected as selection lines and XC is the we have to place now. X ka weight. X ka weight you tell me now here. X ka weight is how much now? Order we have now. This is X, Y, Z. X ka weight is what I will have 2 square. So that is equal to 4 na. Now place it. Right. Now you can tell me. So how to give the numbers now first. So we should give 0 comma 0 plus 4. 1 comma 5. Next 2 comma 6. 3 comma 7. Right. Now you can tell me now f of x comma y comma z, which is equal to what? Tell me now. So x is connected. So which has to be taken, a lower bound or upper bound? X connected means upper bound to be taken, that is 4 is taken. Next here 0 connected means both are not required. X bar connected means lower bound. 1 connected means both has to be taken. So finally this is what I can say, tell me now. 2, 3, 4, comma 7. So the option A. Right? Next, now you can tell me this one. Now here the expression you see this thing y, which is nothing but what? Tell me now. A XOR B XOR C na. 3 input XOR gate. So what are the min terms we know now? That is 1, 2, 4, 7. Min terms are what you see this thing 1, 2, 4, 7. Tell me now here. A, B, C we have to connect now. So tell me the give the numbers now here. 0, comma 1, 2, comma 3, 4, comma 5, 6, comma 7. That is XOR gate. XOR gate. This is the expression. Now you can tell me now here. In this case, so 1, 2. So 1 is given now. So this is the upper bound now. So this should be connected C. 2, 3, 2 required. That is C bar. 4, 5. Only 4 required. That's why C bar. 6, 7. C. 7 required. So then what's the option you see? Option C. Next one. Design 4th class 1 marks by using 2 class 1 marks. How many marks required for the designing? So we'll simply divide them. 4 by 2 will come it as 2 na. 2 by 2 will come it as 1. Totally how many mux required? 3 are required. And this is in the level 1 and this is in the level 2. Level 1, so here if I want to implement the expression y of a comma b, level 2 will connect MSB will be connected. So that is what I will now A, and here we connect the B will be connected. Okay. Next. Tell me now how many mux required here in this case. 8 cross 1 mux. So this is 8 by 2 which is equal to 4. 4 by 2 equal to 2. 2 by 2 equal to 1. So totally how many now here? 7. And this is in the level 1. This is level 2. This is level 3. So if I want to implement this 8 cross 1 mux, so 3 are there now. So here we have connected MSB. That is A connected here. Next is B and next we'll connect the C here. Okay. Next. 32 cross 1 using 4 cross 1 mux. Tell me now here 32 by 4 which is equal to 8. 8 by 4 which is equal to 2. Yes, 2 by 4, this will be taken as 1. Even less than 1 also fine, but here we should take it as what will be minimum 1 mux to be considered. And here this is, we can say 2 cross 1 mux. In this case we have 2 cross 1 mux. 11. And this is a level 1, so this is level 1. And this is level 2. And this is level 3. Here MSB is connected. Here MSB connected. So means A connected here. Next here will connect the B comma C. Here will connect this as D comma E is connected. 8 cross 1 mux by using 4 cross 1 mux. Tell me 8 by 4 which is equal to 2, that is 2 by 4 which is equal to 1. So total it is 3. So this I can say this as L1, this I can say this as L2. And here will be connected MSB. So that means here we have connected A, this is B comma C connected here. Okay. Next, demultiplexer. Demultiplexer is the opposite operation of the multiplexer. Earlier we have 2 power n inputs, 1 output. But here we have 1 output, so 1 input, 2 power n outputs are possible. This is called as a one-to-many data distributor, one-to-many circuit. Okay. And here the general form is what I mean, 1 input, 2 power n number of outputs. One fellow is available in the different locations. Next here like this. Here we have only one input. This is the input now, one input I. The input is available in the different locations. And these are the outputs. Now here this is my input I. So agar input, if I given selection line is given 0, so this means this connection will establish. That means the input which is available at the Y0 पर available I, Y1 पर कुछ भी नहीं है. If I given S is equal to 1, So that means what happens now here, y0 पर कुछ भी नहीं है, so this is 1. Understood? And this is a dmux working. Okay. So this y0, which means what we can say now, s bar into I. This is equal to s into I. Now you see this thing has 1 cross 4 dmux. So if you are given 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, we have given the data output is available at, so y0 per available either data. So 0, 1 here available, y1 per, 1, 0 here, 1, 1 here available. And remaining locations we have 0, 0, 0, कुछ भी नहीं है. Okay, this is the working of a dmux. Now take this problem. Now they are asking to find what element of where this I13 is available. So first of all this I13 हमने बाहर लाना पड़ेगा. So this is I13 has to come out here. I13 to come out here, what should be the values I need to give you, tell me? What I need to give you, tell me now here. So this is 1, 1, 0, 1 has to be given na. Then only I13 बाहर आएगा. Isn't it? So this is 1, B value 1, D value 1, D value 1, D value is 1, C value 0, A value 1. So 1, 1, so will come it as what element of 0. 1, 1, so this a NOR gate will come it as 0. 1, so it will come to be a what element, D value 1, so will come it as 0 na. So here this is D bar. Okay, D bar means this is 0. Then this is 1. Here will come 1. 0, 1. It is 1. So 3 na. So it is available when you tell me now at 3 per available I. Okay. Okay. Next one. Decoder. Decoder is a multi-input, multi-output logic circuit which converts coded input into coded output. Okay. The general structure of decoder is n cross 2 power n, n cross 2 power n, where n is a number of inputs, 2 power n is a number of outputs. This is a decoder, n cross 2 power n. So if we have taken now, these are the n number of inputs, n inputs, and here we have a 2 power n number of outputs. 2 power n number of outputs. Now let's see the working of this decoder. If the enable is 0, irrespective of the inputs, all the outputs will come it as 0, 0, 0, 0 will come. Okay. Enable is 1, then only it will come karega. Okay. If enable is active, so when we have given 0, 0, we have given the input. So correspondingly this y0 is 1, remaining all values are zeros. 0, 1. So y1 is 1, remaining all values are zeros. 1, 0. So this is 1, remaining all values are zeros. 1, 1. 0, 0, 0. Okay. Next. In this case, if the enable bar is 1, that means enable is 0. Then irrespective of the inputs, all the outputs will become 0. Okay. If enable is 0, then only a काम करेगा. Okay. Now 0, 0 we have given, this is 1. This is 0, 0, 0. This is 1, 0, 0, 0. 1, 0, 0, 0. 1, 0, 0, 0. Okay. Next. In case of active low decoder, if this is 0, irrespective of the inputs, we'll see this thing, what will come the outputs. Can you guess now what will come the output? So this will all will becomes 1. So because of this active low now, bubble is there, it will becomes 1 now, that's why it is 1. Because of these bubbles are there now here. Because of these bubbles. This is, so this value 0, remaining all values are 1. 0, 1. This value 0, remaining all values are 1. This is 0, remaining all values are 1. 0, remaining all values are 1. Next, in this case, enable bar we have taken. So if this is 1, irrespective of the inputs, if it is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Here you tell me then. If it is 0, irrespective of this, all the values are 1, 1, 1. 0 diya to, then this value is, what tell me now, 0. Remaining all values are 1. This is 0, remaining all values are 1. This is 0, remaining all values are 1. This is 0, remaining all values are 1. Okay. Now you can see. Find the functionality of the circuit. Working of the circuit. This is called as a tri-state buffer. Here we have tri-state buffer, three-state buffer. So you can see now the working, we can comment about what tell me now here based upon the input and output combinations. Now let us take one tabular form here and we'll see it now. Here we have taken the inputs now, those are C1, C0, and we'll see the output of this decoder and thereafter final output. So here we have C1 and this is C0. Next outputs. And this is 0, O1, O2, O3 and this is finally Y. Now you tell me now here, if I given 0, 0, what happens? Next 0, 1, 1, 0, 1, 1. Tell me what I'll get. 0, 0. When you have given 0, 0, we have given whose output is 1, you see this thing. This output is 1, remaining all values are zeros now. 0, 1 means this is 1, remaining all values are zeros. 0, 0, this is 1, 0. 0, 0, 0, 1. Okay, now, so when this is 1 here, so this is on. We'll get the output will come to be जो हमने input में दिया P given ना, so P will come as output ना. When this second case, so this is 1, remaining all values are zeros na. So that means for this one they given Q is given. Next, in this case, what happens now here? What they given you see. This is 1, this is 0, zeros. Will come it as what R will come. In this case, S will come. Check करके बोलिए. Now, so that means what I should call the circuit, you tell me now. What is the circuit we can say now here? Now here we have taken C1 and this is C0 and this is Y. We are given this 0, 0, we are getting it as P. 0, 1, I am getting it as Q. 1, 0, I am getting it as R. 1, 1, I am getting it as what? Tell me now. Yes. So from this, what I can call the circuit? To tell me now. From this, what I will call the circuit? The circuit is nothing but multiplexer only na. This is nothing but 4x1 mux only na. So this is an option, isn't it? Next, take this one. A logic circuit consists of two 2x4 decoder as shown. The output of the decoder they ask you to find. Hmm. And see why this given this information, you see this thing. This information is given to identify which is a LSB, which is a MSB they given. So you can see now D1 is 1. D1 is 1. When it is 1, you tell me in case of 0, 1 case. 0, 1. So this A1 is 0. A0 is 1. From this we can say now. This is A1, A0. This is the order. Okay. A0 is LSB. A1 is MSB. Okay. So first thing. Thereafter here what I'll get this output, you tell me now here this is D2 means what? So this is so A1. Here will commit as what, tell me now here this is A1 A0 bar and this is A1 A0. When I multiplied these two will commit as 0 will come. Here this input is given as C. And here what will come here? This is A1 bar A0 bar plus A1 bar A0. So in this case F is given as what, tell me now? R gate na A1 this is A1 bar A0. A1 bar A0 bar plus A1 bar A0 which is equal to A1 bar. A1 bar C now, so that's why C bar. Got it? Next one. Implement 4x16 decoder using 2x4 decoder. Four cross 16 decoder using 2x4 decoder. Here the same thing. We should division. We should do here. 16 by 4. How much you tell me now? 4. And 4 by 4 which is equal to 1. So that is how much now? 5 now. So we got this as a 5. Now so as usual, so this is what we can say now. This is L1. Here this is L2. And this L1 here should be connected. MSB short connected here. So this is now MSB. If I say A comma B here connected, here C comma D is connected here. 4 inputs required. Next, implement 3 cross 8. 3 cross 8 by using 2 cross 4. Again 8 by 4 which is equal to 2 na, and 2 by 4 which is equal to 1, I can say that is 3. And this is a level 1 and this is a level 2. Here MSB connected, that is A. If I call this as B comma C. Okay. Now done. Next one, encoder. And what is encoder is a? Encoder is a combinational circuit which is used to convert one form of code to another form of code. One form of code to another form of code, we use an encoder. Right. And so here if you want to convert the octal to binary, we use the 3 cross 8 encoder. Decimal to binary, we use a 10 cross 4 encoder. Hexadecimal to binary, we use 16 cross 4 encoder. Okay. Now the general structure of encoder is opposite to decoder, 2 power n cross n. So this encoder working is little different compared to the other. So if we have taken this inputs now here, you can see, so A and B, when you have taken this as this inputs, let us say we have taken this input is 0, this is 0, and 0, this is 1. So now whose input is 1? I0 input is 1. So this I0 suffix is what I mean 0 now. 0 will come it as here. This will come corresponding to 0 will come as output. When I have given 0, 0, 1, 0, tell me what happens now here. Whose input is 1? Tell me I1 is 1 now. So that means output will come it as 1. That is 0, 1. If it is 0, 1, 0, 0, 1, 0, 0, 0, then see what happens. This will be 1, 0 will come, 1, 1 will come. And understood this point? Tell me. And you may ask one thing. The thing is, here I have taken at n only one input I have taken as 1. If more than one inputs are 1, then we'll get something will come, but that is some random value, that is not a valid output. Understood what I am saying here? Agar if it is, let us say 1, 1, 1, 0 we got, we'll get something will come, we don't know, but that is an invalid output. Okay, that is not a valid output. Okay, so that is an invalid output, we can say 0, we can place invalid case. So valid case we can say 1. That is the disadvantage of this encoder. Encoder is at a time only one input must be 1. If more than one input is 1, so you'll get some random output will come. Okay. Next, the drawback. So for an encoder at a time, so here only one among all the inputs is high and remaining inputs should be 0. If multiple inputs are simultaneously high, then the output is not a valid. To avoid this restriction, we are using the priority encoder. To avoid this problem, we are using a priority encoder. Okay. Now let's talk about what is a priority encoder. In this priority encoder, we'll assign some priorities will be assigned at the designing only. The priority encoder is like this. Let us consider, I am assuming my priority is like this: I3 greater than, I2 greater than, I1 greater than I0. This is my priority we are assuming. Okay. So once if it is 0, 0, 0, 1, so what will come here? What will come here? So that is 0, 0 will come as output. Okay. Let us say we have given this as 0, 0, 1 we have given. If I1 is 1, if the I1 irrespective of I0 will come, the corresponding output will come for this I1 output will come. That is 0, 1. 0, this is 1. If it is irrespective of this one, this I2 has high priority compared to this thing now. So corresponding to 2 will come as output. If this is 1, it doesn't see the remaining fellows. Corresponding to that will get output. Understood what I am saying here? When the high priority is 1, it doesn't see the remaining things. It will focus about corresponding that only will see that one. Done? All of you. Done. Fine. Yeah, okay, that's it for today's session. And all of you do like and share to all your friends this about this session. And the next class we will talk about the sequential part. And mostly you tomorrow may not be, day after tomorrow we have continuation class of sequential part. Okay? Okay then. That's it. We'll meet in the next session. In the next session we will discuss the sequential circuits.